Today we shall look at the topic angle at the center and angle at the circumference. We'll start off by looking at the symbol for circumference. The symbol is annotated by this. It looks like a capital letter O with a dot at the center and a superscript CE. Here we have angle AOB, which is the angle at the center, and this angle is subtended by the arc ACB. Subtended here simply means bounded. We have another angle APB, which is the angle at the circumference, and this angle APB is subtended by the same arc ACB. We shall now go on to measure these two angles. The angle at the center is 80 degrees and the angle at the circumference is 40 degrees. The angle at the circumference of a circle subtended by an arc will always be twice the angle at the circumference subtended by the same arc. Now, this property, angle at the center equals to twice the angle at the circumference, only holds if they are subtended by the same arc. In general, if angle APB here is x, angle AOB will be, 2x. Now, let's say we shift the point P here to the right. The property angle at the center equals to twice the angle at the circumference will still hold because angle AOB and angle APB are still subtended by the same arc ACB. Now, if we move the points P a bit to the left such that AOP is a diameter, the property angle at the center equals to twice the angle at circumference will still hold because they are still bounded by the same arc ACB. Next, we shall shift the point P even further to the left. Are the angles at the center and the angles at the circumference bounded by the same arc? Yes, and hence the angle at the center is still twice the angle at the circumference. Now, what happens if we shift point P all the way here to the bottom? Is the angle at the center and the angle at the circumference bounded by the same arc? Now, angle APB is subtended by the arc ADB here, whereas angle AOB is subtended by the arc ACB. And since they are subtended by different arcs, we cannot use the property angle at the center equals to twice the angle at circumference. Now, if the angle at the circumference is angle APB, where is the angle at the center? Now, since angle APB is subtended by the arc ADB, to find the angle at the center, the angle must also be subtended by the arc ADB. In this case, the reflex angle AOB is subtended by the same arc ADB, and hence reflex angle AOB is the angle at the center. Therefore, if angle APB is the angle at the circumference, the reflex angle AOB will be the angle at the center. To recap, reflex angle means an angle that is more than 180 degrees. And so, reflex angle AOB will be equals to 2x. Next, let's look at some examples here. In the diagram, O is the center of the circle and angle LOM is equals to 85 degrees. We are asked to find angle LKM and angle LNM. Angle LKM is simply 85 degrees, divided by 2 because of the property angle at the center is equals to twice the angle at the circumference. And hence, to find the angle at the circumference, we will need to divide by 2. And we'll have 42.5 degrees. Once again, do take note that angle LOM and angle LKM are subtended by the arc LM here. To find angle LNM, we will simply need to divide 85 by 2 as well, because of the property angle at the center equals to twice the angle at the circumference. And LNM is also 42.5 degrees. Again, do check that the two angles LOM and LNM are subtended by the same arc. In this next example, O is the center of the circle If angle ROP is 110 degrees, find angle OPQ here. To find angle OPQ, in order to find angle OPQ, we'll first need to find the angle RQP, which is equals to 110 degrees divided by 2. Because of the property, angle at the center is twice the angle at the circumference. We can apply this property because the angle at the center and the angle at the circumference are subtended by the same arc, RP. And angle RQP will be equals to 55 degrees. Since angle RQP is equals to 55 degrees, angle OPQ is also equals to 55 degrees. Do you know which angle property this is? Yes, this is the property base angle of isosceles triangle. In this example, O is the center of the circle with angle ACB equals to 125 degrees. We are asked to find angle AOB here. Now, can we straight away use the angle property? Angle at the center is twice the angle at the circumference? No, we can't, because angle AOB is subtended by the minor arc here, while angle ACB is subtended by the major arc. In order to find angle AOB, we will first need to find the reflex angle AOB. Since the reflex angle AOB and angle ACB are subtended by the same arc, we can multiply 125 degrees by 2 because of the property angle at the center, which is the reflex angle AOB, equals to twice the angle at the circumference, which is angle ACB. And we will have 250 degrees. Finally, to find angle AOB, we'll simply use 360 degrees minus 250 degrees because of the angle property, angles at a point. And we'll have angle AOB equals to 110 degrees. In summary, the angle at the center is equals to twice the angle at the circumference. And these are the angles at the center. And the angle at the circumference will be half that angle. Do take note that in order for this property to hold, the angle at the circumference and the angle at the center must be subtended by the same arc. The last example here is slightly different from the rest because the angle at the center here will be the reflex angle. Now, an easy way for you to remember this is the angle at the circumference and the angle at the center will somewhat look like the same shape. In the first example, the two angles are curved in somewhat like a U shape, while in the last example here, the angles are curved in somewhat like an N shape. In our previous example, if the angles at the circumference is here, this cannot be the angles at the center because this is curved somewhat like a U shape, whereas this is curved somewhat like an N shape. Therefore, the angle at the center is actually the reflex angle instead. That's all for this topic.